Section 1.8b is about drawing graphs. We're going to use the information that we've learned in the last video to go ahead and draw a graph for a situation. Our situation is the electronics store is having a sale. For every 2 DVDs you buy at a regular price of $29 each, you get a third one free. Now we have to make a table for buying 1 to 5 DVDs. Sometimes you could make a table up and down, but because of the space that I have here, I'm going to make my table left and right. So let's call the top the number of DVDs. Now why am I doing that? Because the number of DVDs is my independent value. It's the value that is just bought, and then the cost for those DVDs depends on how many I buy. So we put the independent on top and the dependent on the bottom. Now we want to do 1 to 5. So for 1 DVD it's going to be $29. Then the cost of buying 2 DVDs, again that's another $29, so $58. But now I get the third one for free. So the third DVD is going to be $58 because I don't pay any extra for that. The fourth DVD will be $87, and then the fifth one, if I add another 29, will be $116. If you want to take a calculator and verify that, you can. So that's a table of values, independent on the top, dependent on the bottom. Now I'm going to write those as a set of ordered pairs. Remember, ordered pairs, we write the x value first and the y value second, or the independent first and the dependent second. So I'm just writing these as x and y values because what I'm going to do is I'm going to graph them on a coordinate plane that you see at the right. So now I'm going to draw a graph showing the relationship. So over here, my x value, again, that's my independent, so I'm going to label the bottom values as the number of DVDs. It's important to label so you know exactly what numbers go down there. And since our independent value goes by ones, if I were to label these 1, 2, 3, 4, 5, it'd be kind of a short, narrow graph. So I'm going to space them out by 2s. I'm going to make this 1, this 2, 3, 4, and 5. And you can make these graphs any way you want. I like to space them out a little bit and use up more of the graph. It's easier for me. Now the dependent value is the cost, so that's going to go along the y-axis on the side. And again, I don't know how I want to do these, so I'm going to go every 3 spaces will be 30. So this will be 10, 20, 30, 60, 90, 120, and then 150. Now we're not ever going to get up that high because my y values go up to 116, but that'll be a good spacing out. So now I'm going to graph my points. So I got to graph 129. So here's 1 on the x-axis, or the independent, and about 29. Do your best to estimate. And then 258. 58 will get close to 60. 358. So put a dot there. 487. And 5, 116. And there you go. And that's what the graph looks like of this situation. Again, independent values along the bottom, or the x values, and the y values or the dependent values go along the side. We have a couple definitions now. The first one is a relation. A relation is a set of ordered pairs, and you can make any ordered pairs you want. I think for consistency I'm going to use the same ordered pairs that I had on this slide. So I'm going to use these 5 ordered pairs that we had in our last example. Now because they're a set, I use squiggly brackets to represent them, and then I write my ordered pairs this way. So this is the set of the 5 ordered pairs from my example with the DVDs. And that's all a relation is. It's just any set with ordered pairs in it. Now a domain is the set of values of the independent variable. Remember, the independent variable is typically the x values. So when I go up to this relation, I'm going to make a set made up of all the x values. Well, what are those? 1 is the x value, 2, 3, 4, and 5. Those are all the different x values that I used in that particular relation. And so whatever your x values are, those are the values that you use in the domain. Now the range is the set of values for the dependent variable, or the y variable. So let's go back up to the ordered pairs and make a set again. And that set will include the number 29, 58. Now I don't have to include 58 again because it's there twice, so now 87 and 116. So that is the range. That's all the dependent variables. And so in the next couple of examples, we're always going to be on the lookout for the domain, all the independent values, and the range, all the y values, or the dependent values. Here are some examples to work through that talk about graphs that we're going to examine and draw. First one here is there's 3 lunch periods at a school cafeteria. The first period has 352 students, the second period has 304, and the third period has 391. And you're supposed to make a table showing the students and the lunch periods. Well, we did this in the last example. A fairly simple table would look like this, listing the period and the number of students. Again, let's just do a quick talk. The period would be the independent value, and the number of students would be the dependent, because the students depends on what period they're assigned. So now we're asked to write the data as a set of ordered pairs. So we simply take those and put them into parentheses, again using the lunch period as independent and the students as dependent. So there would be my ordered pairs. Now we want to draw a graph showing that relationship like the one we did before. I put the period on the bottom with the number of students on the side because period is independent and the students is dependent. I use this little line break here to show you that there's a large distance between 0 and 300. And then we just put 3 dots on there. First with the x value and then the y value, the x value and y, and these should represent the 3 ordered pairs that we wrote on the last slide. Now you probably want to pause the video and write these down because they take a little more time to write than it just does for me to show you. Here's another example that you can do on your own. Just pause the video and fill the things in as you see. So on the first day, car sales were 5 cars. The second day, the sales were 3 cars, and the third day, 8 cars. So there's a table of values showing that, and then 3 ordered pairs using those values. Now you're being asked to graph and to show that relationship. Again, pause the video and do that on your own, and then check it out. Here's what your graph might look like. I jump by 2s here. You don't have to do that. Everyone's graph might be a little different with the 3 ordered pairs put on the graph. Now we're going to talk about domain and range. Mr. Marr is taking his biology class to the zoo. The price is $4 per student, and 120 students is the maximum. At most means the maximum. And we want a domain and a range. Well, remember the domain is the independent value. Does the number of students affect how much it's going to cost, or will the total cost affect how many students? Well, obviously, however many students go, that will affect what the price or the cost will be. So 0 to 100 would be the number of students that's going to go. That's going to be your domain value because that represents your independent. And then the cost is $4 per student, which means from 0 to 480. Why 480? Because if all 120 students go and you multiply that by $4, you get 480. So the domain is 0 to 120, and the range is 0 to $480. Then you're going to draw a graph. You have ordered pair 0, 0 as your origin because 0 students will cost $0, so that's the lowest values. And 120 students will cost $480, that's your highest value. So you're going to make a graph with the lowest value having a dot, the highest value having a dot, and then putting a line in between them. Notice the number of students is independent, so it goes on the bottom, and the total cost is dependent, so it goes on the side. The great thing about graphing it this way is you can get a line, so you can guess what it's going to cost for any number of students. For 40 students, you can look up here and say it should cost about $155, maybe $160. If 100 students went, that's going to probably be about $400. So you can do that by referencing the X value and the Y value and looking on the line to see what it will cost. Here's one that you can pause and try for yourself. It's a high school banquet, $25 per person for prom, up to 250 students. So 0 to 250 is the domain, and 0 to 6,250 is the range. Where do we get this number from? We multiplied the 250 students maximum times $25 per student. Now we're going to draw a graph to show the relationship. Here's 0 students went, that would cost nothing, and then here's the maximum of 250 students for 6,250, and then draw a line in between.